So momentum is mass times velocity. Okay? So just like we said with inertia, an object is going to want to stay at the same rate and want to continue to stay on that path unless another force acts upon it to change it. Make sense? How much momentum is involved in this? Not very much, but if we load to unload, and match the force and the ground reaction with that drill, then we've added a little bit more momentum. So that's what's so powerful about those three primary drivers and things we need to think about. The kettlebell is such a great tool for demonstrating momentum and teaching momentum for people, because really the weight does all the work for them. Right? Gravity's pushing it down, and it's pulling us back into that pattern that will allow us to get the desired effect that we want with momentum. Not much to that one. Okay? So why don't we turn the lights back on, and we'll go through a couple other drills for you. Biomechanics is really exciting, I know. Okay, so if we do a deadlift, do you guys want to get up? You got something you can deadlift there? I see a bar in the background.
Just one.
Okay, perfect. I like Deadliest Warrior there at the front of the screen. Okay, so if we do a deadlift in this position, we could do it with momentum, right? Some call this a Romanian deadlift because the bar stays in our hands and we never put it into a dead position, right? So we can use momentum in that pattern and get a desired effect that we want. So we can be able to load and unload that mass with momentum to be able to transmit and reduce that force. If I take 1 foot forward and I go down there and I stop my tempo or change my tempo, I've now loaded one side of my body, my left side if my left foot's forward, my right side if my right foot's forward, and then I can drive back up and stop. So again, every time I change my tempo, it's going to change how that body wants to take that force. So this is what I find really important when we're talking about program design for clients, because by changing the tempo, it's going to change the amount of force that you need. That will also change how much force or how much load you put a client through. Does that make sense?
Yes.
Okay, cool. If we're doing an overhead press now, so whatever piece of equipment that you have overhead, and Jake, I've seen you post some of these videos and they're absolutely brilliant. Every time you push, say, a barbell overhead or a kettlebell or a dumbbell or any tool that you're using, we can use momentum for that. Anytime I change my handprint on a particular tool, I'm going to get a completely different reaction through the body, how I stabilize, how I'm able to reduce that force, or better yet, mitigate that force and spread it through the whole body. So if I change my handprint on a body bar like this and press, the point of application upon the mass has changed, but so is how my body's going to have to react to stabilize and be able to keep it within that same path. And there's another definition of vectors. Okay? Do you guys have any other questions? Or any questions whatsoever? No?
Yes. You're at
The vectors have to do just with the direction of the force.
Yes, it's the direction, it's the line of, if you want to think of it kind of like a line of stress. or that line of force is going to change based on the application of it, so the point in which I start that application at, and the direction in which that's going. So the body, so the body has to react in a different way to be able to control that force, if you will. So it'll want to produce it, reduce it, or transmit it. And the easiest way to think of it is load to unload. So if I'm shoveling hay, because I just finished cleaning my corrals apparently, so I shovel and I move and I create a bit of momentum. In this pattern, I'm able to create momentum, but that line of force is still the same. If I change my handprint, now I've changed more load that's going to be at the bottom of my pitchfork. So when I'm into here, I got much more load that my body has to produce to be able to keep that same momentum happening. Does that make sense?
Yes.
Right? If I change my foot position and I go goofy foot, so I got my right foot forward, but I'm trying to shovel over my left, again, different reaction to the body. So the point of application vectors are huge with your clients, because they're going to tell you, and you'll be able to progress them just by changing their footprint, their handprint, the direction you want to move them, the triangulation, the horizontal distance. That's so powerful for you guys, because now you can have a different way of progressing somebody's client. Now here's what's cool about, I find the most powerful about that, is that when we want to stay within their sphere of function, we want to make them move real efficiently. You saw the video Jake did with Michelle, I can imagine, where he said if your #1 goal is to first keep them within a small sphere of function that they're comfortable in, and you create rhythm and timing, so that load to unload, that's going to be far more effective for them down the road, because they've dealt with an environment that allows for that. Here's the other thing that I found super powerful. If we use a ball, and we're playing catch, so I don't have a ball in here, but I'll pretend I have a 10-pound ball, and someone's passing me that ball, I can toss it, load, and come back. Load, and come back. Now I don't really have, I'm not so concerned about the pattern that I'm going through. Right? I'm not concerned about what my lunge is. I just know I have to catch this before it hits the floor and pisses my wife off. Right? So the beauty part about that is, the sooner you take your clients into a reactive environment that allows them to play catch and get back to playing, whether it's reacting to a balloon, tapping a balloon from side to side, right? I'm doing a lunge pattern in a left and right anterolateral pattern with a reach at the same time. That's force going through their body. It doesn't have to be a tool with any mass whatsoever. And that's the power of biomechanics, and why it's so crucial for you guys to understand that. Is because when I started in the industry, it was all about this, right? Big guns. We're in there jacking them up. You know? The right to bear arms. You guys have that in the States, right? In Canada, we cut our sleeves off, and it's the right to bear arms. Right? So that was the stuff we used to do back in the day. Now we're realizing, well, if I want more force, why would I do this when I could do this? Make sense? So this is how I have my clients do their arm curls. Why would that be?
More force?
More force. Exactly. Are they going to be able to lift more weight?
Yeah.
If their goal is strength and conditioning and they want to get stronger, is this better? Or is this better?
Second.
Second. Because it's always about force, guys. So whether it's the vector that you're applying that force,